Hey, thank you so much. My name's Jonathan Blythe. I proposed this session in November after some discussions with Discovery Cluster co-lead and some other colleagues from NCEI and NASA. And what I had initially intended was for this to be a group presentation. So we kind of divide and conquer. And the idea I picked up and ran with really kind of took over, and I decided to make this kind of a solo presentation. So since we're going to be spending some time together today, I thought it'd be good for me to introduce myself. My name's Jonathan Blythe. I'm the Scientific Data Manager for the BOEM Environmental Studies Program. The studies program's conducted OCS studies for 50 years. We just celebrated our 50th anniversary. Every year, we have approximately $30 million to spend on environmental research to address information needs for ocean energy and minerals development. And my responsibilities in the program is to receive these final reports, their final products when I receive them, publish them to the website, track peer-reviewed articles if people published in journals, and environmental data management consulting for these projects. And also I manage and am the system owner for the ESP Hub, which is a tool I presented at the last couple of summer meetings in 2022 and 2023. So you may be familiar. You might be familiar with that from the past meetings. I will get to the motivation for this session very soon, but I'd like to kind of demo the ESP Hub and where I'm coming from. This is a science dissemination platform, and there was some challenges with the quantity of work we've done in the past 50 years. So we focused it really to the year 2000 to present. Any products that were published since then. But still, the users must sort through thousands of studies. So the old tool that we migrated from, we released this about a year ago, last May. The old tool used a Google-like search tool to sort through studies. And one of the limitations we found, and a really important development, was there are actually two different audiences for this subject matter. We have our scientists who are familiar with the science, and they're really looking for something specific. So they have technical jargon they're using to query in a search tool. And then you have the more general user who doesn't really know about the science, so they don't have the same capability to access that information or precisely find relevant results. So we decided to carve out a completely different application for that more general user. And that's what this ESP Hub is trying to do. It's making this information geographically relevant and easily accessible to them, and leveraging maps as much as possible, because these people usually want to know what's happening in their region or in their backyard. So presenting this information geospatially is an important component, has been for a while, but this tool is built on the ArcGIS online platform, so it's geo-enabled natively. This is what it's intended to do. And we send people from this web interface, which is the ESP Hub, or the Esri Hub, the AGOL Hub, and they navigate. They don't search. They navigate by topic, then theme, and then they'll find research results that are hopefully of interest to them. Another use case is when our BOEM staff go out to speak with the community leaders from the regions. They need a communication tool so they can quickly pull up a map and show relevant studies that they've worked on. So this is really for that engagement that BOEM has to do as part of its regulatory authority. So a little more, this is motivating the session on virtual collections. And but I need to tell you where I'm coming from, and where ESP Hub came from is the marine cadastre. This is the tool to disseminate the marine cadastre is the tool to disseminate cadastral data that supports ocean planning and agency decision making. So that's a real target audience. So what kind of data are these users looking for? How do they access and use the data? Well, they're not going to download the data, and they're most likely not going to analyze it. If they need that kind of scientific analysis, they will hire someone else to do it. But they want to know that the science that BOEM has funded is supported with discoverable and accessible data. They want to know that whether the data is comprehensive and supports the regulatory activities that we're proposing. And then they want summaries of who used the data, how were they used, and what were the findings from that research. So once again, that's the point of putting data in the ESP Hub, is to lend credibility to BOEM science. And this is where I'll go into a brief demo. I didn't want to spend a lot of time on this, but I have, if I can get my browser to work. Wait for that. You're seeing a Slido poll we'll be conducting later. Oops, close that. Here. So here's the ESP Hub. That's the same screen that you saw the screenshot of, and you're funneled through these research topics. So you start with its description, research topics. So I'll pick biological sciences a lot. Most of our research are in the biological sciences. Hopefully that's a term that all of our users would be familiar with and can navigate to. And I'll pick this AMAPS theme. AMAPS is the Atlantic Marine Assessment Program for Protected Species. But we've conducted this research for protected species in the Pacific and the Gulf of Mexico, as well as the Atlantic. So it's kind of a cross national program, if you will. And the data set, the data collection, in fact, that I'd like to highlight here is the cetacean, sea turtle, and seabird visual line transect surveys from ships and aircrafts during the Gulf of Mexico assessment program for protected species. And we click on this card. So this, think about that marine planning user. They, to get to this point, they're actually interested in the data. This is giving them the summary of the data that they're probably going to be satisfied with. But if they wanted to investigate it further, hey, here's a link to the National Centers for Environmental Information. Before we go there, I'd like to highlight this map interface, and this is highlighting the polygon that's associated with that content card. And it's the same as it's drawn from, in fact, this spatial depiction from NCEI. But there's a ton of data in this data set. It's actually not a data set, it's a data collection. And what you do within the NCEI system is then you go to the granule search, and you can see, and I should have pulled this up before in case it's kind of demo glitch, but this seems to be working. There are 9 items associated with this collection. Each one of these has a unique spatial feature. We're not trying to deliver this nuance to our end users, but if someone wanted to find the data, they certainly could. They could dig into this, and we're giving that breadcrumb trail for them to access the data. There's still several steps they have to do to get to it, but we've given them the starting point. So yeah, to me, this collection level metadata, that's appropriate level target for our users to discover data sets. And And probably that's sufficient. They'll be satisfied at the point where they find that there are data. So to go back in time, when this concept of collection level metadata has been around for quite a while, but I have this snippet from a document that Doug Niebert wrote in 2014. It's called Metadata Recommendations to Support Data Discovery and Use. And for context, this was when the federal government was trying to figure out how to federate data from agency catalogs to data.gov and the Geo platform. And so we needed to follow some basic rules about how to structure the metadata. And what this says is that collection level metadata is defined as a homogeneous series of data. Most of the granules in the collection would have the same metadata values, where they only vary in terms of things like the date that it represents or the geographic extent. And the prototypical example for this is satellite imagery. The satellites passing over the same path. The swaths are collected repeatedly day after day. And so what's different is, the place and what day that represents. And that detail can be hidden from the user if they're just trying to discover the data. They can just look at the metadata record that talks about that entire satellite mission. One important point that I think was very forward-looking here is the FGDC, or whoever was responsible for this guidance, argued that discovery is through the parent record, the collection. And then from that, you can refer to the child. Kind of like what I demonstrated with the NCEI collection. We find the Go Maps program with a representation of all the cruise data across the entire Gulf of Mexico. But then you can go a level deeper and find the granules. So here's another, this is going to be, focus for this session. Is I'm going over a lot of the fundamentals we have. And another important fundamental relevant to this session are the data citation guidelines for earth science data. These were being worked on for a while, but the version 2 that I'm citing here is from 2019. So these are 5 years old already. And Mark Parsons said in a session yesterday in the comments, he said, data citation is a settled issue. And that might very well be the case. And this is the definitive guidance for that. So the data citation guidance say that if you're going to cite data, you treat it like a book in a research article. So you would have a reference section where you use a citation style that follows the book format, the book citation style format. But there are a few additional fields you have to add because data are not books, obviously. One important thing that came up very early on in these deliberations on how to cite data is we need a resolvable persistent identifier because of the problem of links breaking. So that was an early kind of guidance that was developed. And once again, kind of consistent with the guidance from Doug Niebert in 2014, it says if you're citing a granule from a collection, you treat it like a chapter in a book where the book is the collection. So you're always citing the data in the context of the collection. So that was 2019, and I thought the matter was settled. I wasn't, at the time all that engaged in those dialogues, and I think they work very hard, and I'm glad for this. But several years later, when I became more engaged in ESIP and the discovery cluster, this came up again. I'm sorry. This came up again in the context of usage-based discovery. So in order to get usage-based discovery tools to work, we needed to be able to harvest data citation from DataCite and other indexers. And one of the findings was from these initial efforts is, well, it's not really happening, or if it's happening, it's not as consistent as we'd like, as we'd expect, given how clear these standards were. So they are simple and easy to follow, but there is some challenges that we have. And also, I think it's fair to say, although I don't work at a repository, that the repositories are also having trouble figuring out, how hard they have to work in order to support the data citation guidelines. They're doing very good work to support this simple use case, but the real world use cases might be a little more nuanced and might break down the feasibility of data citation. So I'd like to take an opportunity to start this Slido poll and to gauge the audience and your experience with data citation. I guess what I need to do is switch over. If you go into the Kiko chat, there's a tab called Slido, and you can respond. This survey is open there. And the instructions here are, I'm giving you date ranges so we can get a sense of how long ago when you thought you first encountered these benchmarks for data citation. But just for reference, if you have limited experience or you still don't think you've encountered these benchmarks, just leave the answer blank. There's no required questions. And I'm going to give us about 5 minutes. So to respond, I'll just be quiet. And then we'll come back as a group. So let's see, the Kiko chat. No, this one. This is what the survey should look like. I heard some feedback that these faces were hard to use. I wish I'd done it 1 to 5, but if you like the data citation guidelines, just put the hearts in your eyeballs, like you're having a great time. But if you're having trouble with data citation guidelines, that's, obviously the left side, the unhappy face. Okay, I'm going to be quiet for a little bit while people respond. All right, so this first question is, when was it first you read or authored a research article that gave credit to data? And a lot of people, I picked a 15-year span because this is like early years in the 90s, early 2000s. It seems like about half, a good portion of the people can cite that as their first data citation. I think data citation goes back even further, but it's not. That's what the second question is intended to distinguish. Data citation may have been very informal before the internet era, right? That's why there's nothing from before the 90s. So it might have been actually in the document, in the publication itself. So it's a little bit harder to recognize today. But this is really like in the modern age, the internet age, when you could actually click on a link in an article. And articles back in the 90s were generally on paper still. So there's very few examples of this. There might have been like a data science journal, which was already on the web. And so they're using resolvable links for data. But once again, it's really interesting. There's a split like the 2000s versus the current day. About a good portion of people are familiar with this from the early 2000s, and then some people more recently. And I think this is a bimodal trend, which might reflect underlying demographics in our audience here, which is interesting. Okay, so when did you hear about the Earth Science Data Citation Guidelines? And this is really good to hear. This means that we have a lot of early adopters. Pre-2015, 40% of the folks have heard about it. And then the other half, more recently since 2020. So, also bimodal. And have we achieved what we consider to be suitable data citation guidelines or practices? And this is really encouraging. I'm so happy that people have already achieved this and, well before 5 years ago, because that, was not my general impression from the discovery cluster. So maybe I have to reassess that presumption. But there are a few people who still, just recently, 2023, are starting to achieve this. And in general, people are pretty happy with the guidelines and how easy they are to follow. There are no unhappy faces. That's very encouraging. All right, so let's move on with the presentation. How do I do this? Yeah, and that's generally my my experiences. I've just kind of taken it for granted. Data citation guidelines have been out there for 5 years, and when they were released, I accepted them on face value. And that was around the same time that data management became an agency priority. So, it takes a while for the uptake, but, in spirit, we've all kind of signed on the dotted line for these guidance. And it's just a matter of time before we all are able to implement them. So I'm going to keep going down this line. It sounds like we have a lot of early adopters, so this might be very, elementary material, but soon I'm going to be kind of going into some nuanced material that hopefully will be new to some of you. So what are we citing in articles? And on the right, I have an infographic. The top, it's supposed to be a research article. There's a link, that black thing, that vector diagram. Then there's a web resource that the article links to. And then below that, there's the data that represented like these disks. I'll show this figure a couple times, so I just wanted to orient you. And so what we're talking about here is that there's an article, and the links from the article have to go to this dataset landing page, this web resource. And that's the best practice accepted by the earth science community with these, permanent or persistent links. That because, sometimes you have to upgrade your website. Maybe you change the organization's domain name. So you have to change the link sometimes, but if you have the persistent link, you can maintain that fidelity. And one thing that this kind of assumes, though, is whichever repository is hosting the data will be responsible for hosting these landing pages. And that way they can maintain the links and keep a tight coupling. They will also maintain the DOI redirections, so keep everything up to date. And I guess another assumption implicit in all this is that the repositories are long-term archives. That's what we're trying to maintain these persistent links for, but they don't always have to be. They can be other kinds of repositories. The same citation guidelines would apply for that. So where do we run into some nuance in the data citation guidelines? Well, there we could work really hard, say, to codify the relationship between a data landing page and the data, and make those links to data very, machine readable and actionable, so that we're getting a precise, say, like a subset of a collection. And these can be supported dynamically. There's this dynamic citation guidelines that's cited below. And thank you, Mark Parsons, for bringing this to my attention. When I talked about this session with you earlier on, I was totally unaware of this. And so, I'm excited to share something that I've learned. How does this work? Okay. The repositories or archives need to have a catalog or metadata system. And so there's some maintenance involved in dynamic citation that the repositories would have to accept. Sometimes there's documentation that goes with data that's important for understanding the collection. So we need to keep track of that also, and know when it applies to the dynamic citation so people get a full package. Data quality is a huge issue here, because often people want a complete collect a subset of what they're using. So like if they're looking for all the data from a specific region, they want a very precise way to subset that collection. And then we have some edge cases where this produces a proliferation of data set landing pages, which in an extreme case might result in one landing page for data for each time any article cites data. And so that could be a problem. I'm not sure. And I think that's a bigger issue that people are trying to resolve with giving due credit. Because if you inflate or really you're increasing the number of citation targets, that's going to decrease the value of any given citation. And then that undermines the whole purpose of the citation metrics. Another thing I'd like to point out about this is, I'm not being too critical here, but I think repositories, if they followed the dynamic citation guidelines, they would be serving up what I consider to be a hot mess, and leaving the end user with the responsibility to figure out how to navigate this in these complex data situations. And, they might be writing an article where they're pulling data from several repositories, and they have to navigate each repository system, which may be different. So there's a real potential issue here. Another problem that I'll point out is, and this is well documented in the data citation guidelines, is sometimes we would point to, from a research article, to the repository or archives homepage, and that's all the linkage we provide. So it's like dropping you into, okay, here's where you can find data. Good luck. Hope you're successful if you wanted to find them. Or you could actually, this happens a lot. It's not a great situation, but it's the reality. You could actually say in the article, in the methods section, we went to this repository, we went and subsetted using these parameters or whatever, or we contacted this person. So they give you a contact information. Or even if there's like a request protocol. But the point is, the data is not actionable. So there's additional guesswork that the user has to do. This leaves them a cold trail. Potentially they'll never be able to definitively address this ambiguity. So the middle way, which I'm proposing here, what's the just right solution? We need a solution that defines the relationships among the resources that the scholarly article needs to cite. Okay, so we don't we have a consistent and logical way, not that they don't have to navigate the complexities of each repository's metadata system. But it shouldn't leave them in a cold with a cold trail. So actually, this comes from the data citation guidelines. I just copied the text out here. For the use case that I'm exploring, the ESP Hub, we generally have small collections, so a small number of files. And initially exploring this, I just looked at NCEI accessions. So that's kind of how I've defined it for the purpose of this exploration. What they recommend in the data citation guidelines is to use the ORE resource map. And that provides a just right solution for this use case. And but with one slight addition, and that's what I'll call virtual collections, which I'll get to present later after a short breakout session. So I feel like I've been talking a long time. I have been talking a while. So we have about 15 minutes now that I'd like each of the groups to break out, and Annie will help us determine how many people, but I wanted to just give you these instructions, which I also provided in the document. It's bookmarked on page 2. And in your breakout, each of you should introduce yourself, your name, affiliation, experience with data citation, and then talk about whatever you like. Hopefully it's something about data citation and relevant to this session. I'll be joining just one of the groups, so the other group will be the community fellow will be participating in. And you don't have to tell me anything. It's if you want to be critical of this presentation, that's great, and we can use that in the discussion at the end. But for scaffolding, if you have any need to structure your discussion, I'm providing these questions to help scope what we're trying to accomplish in data citation. So I hope this will be useful, not just for this session, but for other discussions and other sessions on data citation that are coming up in the rest of the meeting. So with that, I think we could start the breakout, and I'm going to start a timer as well.
Okay, I'm going to go ahead and create the breakout rooms. So we have like 3 to 4 folks in each. I'm going to create, actually, how about 4 breakout rooms?
Okay.
And everyone will just pop in there following Jonathan's instructions. So we'll see you back. And Jonathan, we said 10 minutes total?
15.
15, okay.
Because we want people to have time to introduce themselves.
You bet. Okay, everyone, I'm going to go ahead and create these.
Thank you.
Jonathan, are you there?
Hi. Yeah, sorry.
Yeah,
Thanks,
I'll just finish.
Go
Just
ahead and
finish
finish, Beth.
quickly that, as long as we continue archiving data in that way, we need some method of referring to the specific data sets in there. Because if you have a collection with 100 data sets in it and somebody cites that, it's hard to know which, specific variables they used sometimes.
Hi,
Well,
Beth.
thanks so much, Beth. We're back in the full session now.
Hi, Doug.
Beth's on her iPhone, so she probably can't tell that.
Yeah, I know. I'm really I'm trying to multitask today, so
No, that's fine. So I think we had a lively discussion in my breakout, and I hope you guys did as well. So I hope that'll be kind of a useful useful scoping session for the rest of the meeting and for the discussion later on in this session. But just for my benefit, if you guys can use the reactions button at the bottom of the Zoom window, I want to know if the concept of data collections came up in your scoping. Wait a second. And if it was a positive reference. So like, is this part of the solution, the long-term solution to the data citation, the uptake and adoption of these guidelines? So you can put a thumbs up or whatever you like if that did come up. And I'm not seeing. Oh, there's, okay, I have to look at the people. Okay. Let me look at the gallery view. Anyways, someone will have to tally that for me because I'm having technical challenges with Zoom. My own issues, not anything wrong with the platform. But I saw at least a couple thumbs up, and that's great. In my group, it was a bit mixed. So just stay with me because I think it does. I think it does have a place, probably for even the types of data that Beth works with, large satellite missions. But my use case is really for smaller collections that the data citation guidelines recommend object reuse and exchange, that standard, which I'm going to go into in some detail. So hopefully this is new for you. If it's not, feel free to correct me if I say anything wrong. So when I was preparing for this session, I was grappling with the issue of how to cite NCEI data in the ESP Hub. And so I took a deep dive into the ORE standard, trying to learn it and implement it in my system. And this is what I learned. So I'll give you kind of like a 101. This is fundamentally about aggregations of data and the way these are referenced in the what's called a resource map. It describes the relationship between the aggregation and the aggregated resources, where the data set granules are the aggregated resources. And the aggregation is some concept that defines this resource map. So concepts do not have or do not resolve to a resource on the semantic web. They are just referenced using a URI that doesn't go anywhere. And so that's just the difference between physical media versus web concepts. And the resource map is structured like a one-to-many relationship. There's one aggregation and at least one, but hopefully more than one aggregated resources. So this is very much like the collection level metadata concept, where each aggregated resource is a data granule. At each level of this resource description, you can have Dublin core metadata. The only place it's absolutely required is in the resource map description, which is the header of the RDF file. Dublin core can tell you like who collected or contributed the data, the date ranges. They use in the ORE a primer, they discuss a friend of a friend metadata. So that's how you describe people or titles for resources. And there's some pretty descriptive guidance out there that I tried to follow. I think it's pretty good and it's ready for uptake. One thing that's relatively nuanced that I won't get into quite yet is there are a few reserved ORE namespace relationships to indicate things like provenance or same as. This resource is the same as that resource. And in the primer, they're showing a web page, and the resources are like different formats for that same web content. So there's some content negotiation, and the different formats are for different browsers and requirements. So if you'd like to learn more about that, there's a good primer online from 2008. It came out a long time ago in my perspective, And this is really the first time I've heard about it when I started researching for preparing for this session. So here's an example, the example of Go Maps that I went over before. There's the NCEI landing page for the collection, and that's my aggregation concept. And then underneath that are 9 aggregated resources, each of the NCEI accessions that contribute to that data collection. And I just noticed yesterday ORE is actually an open archival standard. So maybe, you know, this is deep in the DNA of how NCEI is doing things, and we just don't see that. I'd like to hear back from NCEI if that's the case. But it's really interesting to try to expose this and use this as a interchange format for this metadata as well. So that's how I tried to implement it in the ESP Hub. And you can start seeing things right away. I don't know if you can see my cursor, but there are 9 accessions on the right here, and they aggregate, they all funnel up to this one aggregation concept, and that's defined by the title of the collection level metadata. The URL is, you know, a resource that describes it, and then, yeah, there's the resource map can be cited in, you know, that this resource map describes this aggregation. So it's all very explicit, machine readable, spelled out here, but this is just a concept map representation of it. And when you put it in concept maps and you ask it to, I guess you can organize it horizontally or vertically or whatever, it automatically pulled out 3 different kinds of accessions by who contributed the data. So up here you have Laura Diaz, and she's really looking at the visual observations of marine mammals and turtles. Then you have Allison Sussman, and she was really focusing on data on seabirds. So they're different. Also visual observations, but different taxon. And then down here, Gina Rapucci, it's the marine mammal data, but using a different methodology, the line transect survey. So there's a natural breakout that happens without even trying in the concept map because of the Dublin core metadata I applied to in the ORREs. And then the individual accessions, you can tell by their titles, they're for different cruises. So that's ultimately why there were 9 of these, some combination of data type and spatial temporal extent. So while you're thinking here, okay, ORE is really just about collection level metadata, which is a way to document a one-to-many relationship. But fundamentally, this is a semantic web standard, and it's required for all the resources and the aggregation to have these URIs. And what that does is it allows you to link through the semantic web any aggregation that cites the same resource. And so now all of a sudden you're seeing how things are connected in a many-to-many relationship way through the semantic web. And I think that's really powerful. One of the rules in the primer says that you're not allowed to assert properties of aggregated resources, okay? You're supposed to treat them as a, whoever owns that domain, you're supposed to use their relevant metadata to populate the Dublin core description of the aggregated resource. However, there's an ability to create additional semantics that are specific to just your aggregation. And that's where you would put something like a provenance. Like there's something called a lineage in the ORE namespace. And you can say, hey, this data set was derived from that data set. So there's a lineage here, provenance. And I have an example I can show you in a bit. I think what this does is since we're deferring to the URIs for the data granules, it's not going to end up inflating the citation metrics. At the end of the day, we're citing the data and where they come from, the repositories. We're just putting this ORE semantic web concept here as a mediator, so we can both locate and identify these collections, but also apply unique relationships that are just applicable to this one aggregation. So I'm going to come back after this fun poll. This is going to be a word cloud. And talk more about the implementation, showing you examples from the ESP Hub. But so since that was kind of like a very heavy subject matter, I know it took me a while to kind of digest that. I wanted to do something that's a little more fun. And I'm going to turn the word cloud on. If I can get back to my browser. To go back to this, I'm going to turn this one off. And I'm not going to show the results until I'm going to give you a couple minutes to answer this question. And let me just refer to see if there's any rules about this. So when you think about a word cloud, it's best if you respond with a term. Now, it doesn't have to be one word. It can be a short phrase. But if you have multiple terms, just do multiple submissions, and that will help upvote the responses that more than one people have. And so I'm going to put a timer on it. In 2 minutes, I'm going to reveal my answer to this question, and we'll see if we're on the same page, or if the terms you are thinking of are the same as what I'm thinking of. So what is the term that the US Congress and the executive branch uses to distinguish valuable data in law or laws, rules, and regulations? And if you're not in the US, don't worry about it. Just answer the best you can for whatever your government uses. And so I've got the poll open. Let me know if anybody's having trouble with that. I'm just going to be quiet for the next minute while people respond. Results. Let me view the results. Critical. Give some more time. We have lots of time in this session. Actually, no, we don't. We are burning through time, so I'm going to have to wrap it up. Okay, so let me see. I see the word critical seems to be the most upvoted. There's only 2 votes for that, so don't weight it too much. Citable, sensitive, verified, publication, useful, records, and open. Okay. Well, very interesting. I think that was a good experiment. I think I should close it. Oh, verified. Okay, someone likes verified. There's a thing that happens when you show the results. Now people are like getting more ideas and submitting more, but okay, I'm going to just close it now. Thanks for your input. And I will tell you, I had a completely different answer to this. And the way I designed the question, I was trying to engineer so you would answer the same way as I did. But my terms were data asset. So data asset really implies that the data have value for a specific purpose. the term evidence building, which is new under Title I of the Evidence Act, and agencies are responding to now, and even the definition of data that that the U.S. government uses is you can look this up in U.S. Title 44, Section 3502. So just interesting that we're coming from a different baseline, and that might indicate our different use cases, but who knows? Okay, so now that's a good a segue now to the rest of my presentation. I really hope I don't run out of time, so I'm going to speed through the rest of these slides so we have a little bit of time to discuss at the end. So this is how data collections, and I really wish this wasn't showing my face. Okay. ESP Hub uses data collections to cite data. Okay, and this is something I was just trying to figure out. I was planning to do it anyways, but I've done it really just in the past couple months in preparation for this session. What it allows us to do in the ESP Hub is to create a succinct and coherent story about the data that are a product of that study. We can just send things off, like send people off to NCEI if they wanted to learn more about it. But that keeps us from having too many links to clutter up the user interface. And really, that's a level of detail our audience is not interested in. There's some situations where there's no collection metadata, and that's not a problem because this ORE standard allows us to create a virtual collection, and we can document that on our website. So let me see what slide I'm on. So I'm going to do a quick demo, and I recognize we have limited time, so I'm going to do it quickly. This is a new theme I created in the last couple months. It's called the NCEI Archive Collections theme, and it follows the same web map template we use for all of our themes, except it only has these data collections in it. And we identified roughly 19 of these over that period of time. So if you look at, just take this first one, this is the aerial surveys of marine mammals in the Chukchi and Beaufort Sea. There's actually, I have some slides to discuss this later, so just keep that in mind. But in the web map, that's not in the Gulf of Mexico, that's way up here. And look at that huge footprint for that data set. That's a 40-year data set that BOEM has invested in and contributed data to NCEI repeatedly over a number of years, 40 years. And so there's some great complexity to this data in terms of its temporal extent, spatial extent, because our leasing areas shifted over that 40-year period of time. There's, this Go Maps one, which I showed you before. There's another one that I'll talk about in a little bit. It's the latex A reanalysis. I'm scrolling to that here. Also in the Gulf of Mexico, but it has this polygon here. And this is the level of information I expect most users will care about. And if they really needed to find out more, they could go to one of these links. This particular link is not active because it doesn't link to NCEI. This is one of those cases where I've created an ORE resource map so people can find those links to NCEI from my website. Back to the presentation. I'm glad that the demo is all cooperating for today. So this is that aerial surveys data set. These are data collection. In the relational data framework, these data are duplicated because, like I said, these occurred over a period of 40 years. So there are a number of studies that cite the same NCEI accession. I've color-coded by accession number here. You wouldn't know that these were different except if you looked at the URL for the data. And there's another example here, the red one. So here is a study that cites it. Here's a different study. But here, these two are duplicated only because that same data set is displayed on two different theme pages, the aerial survey page and also the marine mammal page. So there's other reasons for duplication. We just need to negotiate the content, send it to the right place. And also for accounting purposes, we need to have that data associated with each study that contributed to it. And what this results in for the aerial survey theme page is, and this is that one of those places where you can find that data collection, there are now 5 different content cards at the bottom that discuss roughly the same data set. A couple of them are NOAA references, the fishery service references. So they're not the NCEI data sets that I'm citing, but actually 2 of these are NCEI data. And then we have the data collection. So that makes a third. And there's duplication here. We have to go back, and since we figured out with this talk how to cite data, we have to go in and deduplicate the website. And ORE is actually a great tool to do that because it does that automatically in the resource map. You're only allowed to link each aggregated resource once. And so that color coding I showed you before, it normalizes the relational data because it's in this this new format, the RDF format. And so you only see it popping up once. So if we built these data citations based off this data, then we would have much better presentation of that same information to the public. The data collections can tell some other stories, and I'm just keeping my eye on the time. So the other example I showed you was the latex reanalysis. Latex stands for Louisiana, Texas, and A, there's like 4 parts, A, B, C, D. That occurred in the part A occurred in the 90s. And as they do in oceanography, sometimes they pulled the data from NCEI and reanalyzed it using a different model. So they published on those results again in 2000, but they were actually using the data from the 90s. When we initially cataloged the NCEI data, we incorrectly attributed it as a product of the 2000 studies because that was the only place we learned about, hey, there's data at NCEI. But when we created the ORE, we understood there was a little more nuanced relationship here. No, this 2000 study is just citing the data from latex A. They did not collect the data. So we were able to move that in the relational database. We took that data away as a product of the 2000 study, and we put it as a product of the 1990s study. And now it's correctly attributed in the relational database. And we need an ORE resource map with a little more semantic nuance to capture that relationship. So this is what that looks like for the latex A reanalysis. We actually have 2 ORE resource maps. One for the latex A NCEI accessions. You can see there's numerous ones of those, and that's an aggregation. And that aggregation is nested within the 2000 study latex A reanalysis. And in there, there's that proxy of each of the resources and the lineage specified with that ORE namespace relationship. So anyways, I think this is my last slide. And so where do we go from here? And I'm really interested to hear back from you. If not today, hopefully, this is something we talk about in the future on the discovery cluster, or maybe we take it back to RDA. I don't know. We need to find out where's the place, maybe at the next session this afternoon. Maybe we can pick up the discussion there. But there are lots of future directions to take this. At NASA, the GES-DISC has a use case for interdisciplinary data where they're actually looking at data from different repositories. So I've kind of looked at just NCEI data collections, but can we push the envelope a little more and talk about data that are cited? A citation, a research article might just cite 3 of the NASA data sets. So this is a small collection of data. Can we make that happen using ORE? Physical samples, biological specimens, can they be aggregated the same way too? And I have another theme page where I've done that for our biological specimens. You have specimens are like collected from stations, but if you look at a cruise or expedition, the footprint for that is much bigger, and that's the citation target that we have in the ESB hub. So feel free to look at that. And I don't know how this plays with DataCite. Someone mentioned in the comments, can we use the dataset metadata instead of Dublin core? I don't see why not. You know, let's look into that. But my question here is more of, if we invest in ORE and documenting the aggregations this way, is DataCite going to be able to harvest those data citations and give credit where credit's due to the data granules and people who contributed those? And you know, I don't know totally how NASA is pursuing usage-based discovery. They have a couple cool applications they've been developing. I don't know if ORE's been part of that design, or could it be? Could we think of this more as a community standard if other agencies are trying to replicate their success with usage-based discovery? And let's talk about STAC, the Prov W3C standard, schema.org. You know, other standards can play in this sandbox. And so I'm calling for everybody, you know, please come to the Discovery Cluster. I think this is a good venue to discuss this. And in less than 5 minutes, I'd like to take any and all of your questions. I think we can stay after, but I don't want to impose upon you guys. So yeah, thank you very much. Thanks for listening. Let me see if I can get my video on.
And thanks for all the resources that ended up in chat. I like, there was a good amount of discussion in there. It looks like there's a lot of good stuff. So make sure to check out those before everyone takes off.
Right, we can copy those to the document.
Yeah.
Yeah, I put them in the agenda document under the notes down at the lower part.
Oh, great. Thanks, Natalie.
Hey, Shannon, thanks for, it was a good discussion in our breakout. So there are no questions, I take it. That's good. We can go to break early.
All right. Thanks, everyone. I'm going to go ahead and end the session.
Thank you.
Great job, Jonathan. That was really well organized.